Good afternoon, and welcome back to the FANBOY question series. This question will address a concern I have over the validity of the premise that the moon is the reason we experience tides. The moon supposedly exerting a gravitational pull on the Earth's oceans is a postulation that is so full of holes that it's worthy of its own FANBOY series, but that's not what we will be looking at today. Here's our usual source of information explaining the tides as we were all taught in our indoctrination camps. You remember school, don't you? That place where we learnt about Pavlov's dogs in class. Then the bell rang and we all had lunch. As you can see by the diagram, the moon pulls the oceans up as much as 1.2 meters when it's overhead. I find it puzzling that this same gravitational pull doesn't seem to affect smaller bodies of water the same way. The force is a constant. It's exerting the same force on an ocean or a pond. Even your lauded hero, Sir Isaac Newton, once confessed, the moon's gravitational pull on the Earth's oceans is the least satisfactory part of my theory of gravitation. As an example, you're sitting on your boat in the middle of the ocean drinking a cup of coffee. The moon is directly overhead and it's pulling the mighty ocean up 1.2 meters under your boat. But your coffee stays perfectly stationary in your cup. An unknown force is lifting trillions of tons of water in the ocean, but leaving a few grams of coffee completely untouched. Our bodies are 55% water. Shouldn't the moon have an influence on us as well?
Everybody out of the swimming pool, because the moon's coming over.
The purpose of this question is not to argue the validity of the gravitational claim. It is simply to ask, where else in nature does this form of selective force exist? If we take magnetism as an example, a magnet will attract a smaller piece of metal easier than it will a large piece. In our physical, observable world, a constant force will affect a larger mass object less than it will a smaller mass object. A magnet will easily pick up a paperclip, but that same magnet cannot pick up a car. If we extrapolate this easily provable natural phenomena to the moon's alleged gravitational pull on the oceans, then surely the same force should also affect every body of water, however small, in the same way. If your argument is based on a greater surface area having an exaggerated gravitational pull, then how do you explain the well-documented facts that smaller bodies of water can have extremely high tidal displacement, but can also have no tides at all? The Caribbean is a perfect example of a non-tidal group of islands. Sitting between three large bodies of tidal water, the Caribbean islands do not experience tides. The Bay of Fundy has a huge tidal range of about 4 meters, sometimes reaching 16 meters. But Lake Ontario, which is comparable in size and only 500 miles away, has a tidal range of less than 5 centimeters. This is analogous to a magnet picking up a shipping container and leaving a paperclip next to it untouched. Back to the simple question. Is there another force of attraction in nature that exhibits the same highly selective characteristics as the moon's alleged gravitational pull? If so, what is it? Fanboys, please enlighten me.